Okay, I built this circuit using Fallstad, which is this fallstad.com, which said will work in your browser. And it's pretty easy. In here, just do edit, or excuse me, draw and add resistor, for instance, for the source. I just did add voltage source to terminals and got my orientation right. You can hit escape and move that to wherever you want. And then draw, add resistor, and so forth and so on. I'm not going to finish this because I think once you play with it, you get the hang of it. But do take note that this is lab 28 for solid state. Just like that lab, um, I drew the grounds here, and this just says that this diode is connected to that, which is connected to that, which goes back to our negative. So really, there's a line that runs here, but it looks just like your lab, except for one difference. Couldn't figure out how to adjust a potentiometer once I put it in here. If you do that, please let me know. But all I did was break that potentiometer into what it essentially is two resistors that end up being 1K. And our goal here, the very first thing is and notice as I highlight these things, I can see how much current's going through here. I can see 550 microamps is going through there, and 9.5 amps is going through here. And so I'm creating a voltage divider is what I'm doing. If you look here, I've got 9.1 volts, and I've got about 854 millivolts. So all total about 10 volts, which is what my source is. I can right click on it, hit edit, see 10 volts. So what I have to do to simulate adjusting a pot is to highlight this, right click and say edit. Now I can go to 915. And if this side is 915, I'm going to have to edit this, and it's going to become 85 because it needs to total up to be 1,000, 1K. And we can see my current change, and that's pretty doggone close to 5.08 microamps, which is what the very first step of the experiment is asking you to set that to. So just to show you that experiment, I'll bring that window over just as soon as I find it. Here it is. And let me get the right one up, and I'll bring it over to your screen where you can see it. So there it is. There's the circuit. And again, I'm simulating this 1K pot right here just by dividing it into two resistors that'll always total 1,000. And it says just R1, so that we get half a milliamp through here. This is where the ammeter is, and that's where I'm clicking on. And I don't know if it has the 5240. Let's see. And if it doesn't, we'll just have to skip that. But I can right click on this diode, and we've got, yeah, don't have a 5240, so you can skip that, but we do have the 4148 diode, which is what you got there. So you can at least do that part, and any parts you can't do because of not having it. Just make sure you put that in there, but make sure you check first. Don't just assume it's not there. Let's see what else the experiment has to say here for us. Oops, that's not what I'm looking for. Only problem between moving through two windows. Let me find that lab. Check that. Wait, nope, that's not it either. Oh, we'll bring it back up again. All else fails, start over. So bring it over here, blow it up a little bit so we can all see it. And so it says use a 5240 Zener. Now, if we have a Zener, we'll use a Zener. Let's see if we've got a Zener diode. And we'll get to passive components, active components. Add Zener, how about that? So let's see if we've got a 5240. So I may have spoke too soon. May actually have that. So let's see. Default Zener. All right, so I'll choose one that's probably closest to a. Well, this is the default Zener. So let's see what we can set it to. Edit. So I'm not sure what that's going to be. We'll edit model. Okay. So let's put the Zener in there and see what happens. Let's first see what the drawing is calling for. Keep losing these drawings when I bring them over. There we go. So 5240, if I remember right, that's a 10 volt Zener. And let's see what the default is in Fallstat. So let's go back to this drawing real quick. I'll make sure I get the biasing right of the Zener. Here, 4148 gets switched, and then the 5240 goes up and down. So I'm going to play with that a minute. I'm going to pause the video. Okay, I did put the Zener in. I'm currently changing this value. And you can do the same thing here, what it's wanting you to do. Only thing I'll change is the voltage, but you'll get the same idea of what the experiment's calling for. But it wants you to build it with a 1K ohm and, oops, I'm in the wrong circuit. I had to scroll back. Scroll down, there it is. 100 ohm, and adjust our source until we get 1 milliamp. So it says measure the voltage crossing Zener diode. Let's see, construct the circuit and adjust VS until IZ equals 1 milliamp. Of course, you'll be reading these as you go along, hopefully. And I have two screens, that helps, but if not, then just jot down some notes. So let's first change this to a 1K. I believe that's what it was, but I'm going to double check that just to be sure. That was 100 ohm. Okay, easy enough to fix. Easy enough. Edit, take away one of those zeros. So we're looking for 1 milliamp. So right now I've got 13 milliamps, so I'm going to have to bring my source down. So I'll say 5. Read my current. That's too low, so I've got to increase my source. Notice flow has slowed way down, so let's try 6. And I got about 4 milliamps. So I've got to be somewhere between 5 and 6. So I'm going to try 5.5 first of all. See what I get. I'm getting 77 microamps right there. I'm going to adjust my source again. About 6. Getting warmer. Adjust my source again. 5.8. Now I've got some flow. 2.2. So edit. We'll do 5.7. See what it does, because that's where we were in between. Got just a hair over a milliamp, so I'm going to just try to be real precise here. 5.65. See what happens. Pretty close, so probably if I came in here and did an edit 5.66, and this is no different than you having to tweak the knob. There we go, perfect, about 1.0 milliamp. And this is a 5.6 volt Zener, and you're going to find that out as you're making your measurements. And if you remember what a Zener does, it'll be pretty apparent to you. So, and if you look at your experiment, let's make sure we can go to the opposite end. And again, I keep opening the wrong window. And we try to go all the way to 30 milliamps. So we know we can do 1 milliamp. I've got it right there. Let's see if we can get to 30. So edit. Let's take that to about 20 volts and see what that gets us. Oh yeah, there's 140 milliamps. So I know we can get to 30 if we can get to 140. So let's take that down to 10. And there's 43, so you can kind of start getting the feel now. Let's try about 13, 213, and about 73 milliamps. So you can tell right away that we're able to do that inside of Fallstat. And these other little components over here are just extraneous, where I was showing what I get. So notice I can measure right there. I'm measuring 13 volts. Right here, I'm measuring 7.3. And right there, I'm measuring 7.3, which is the drop of this guy. I can get on it there. That's 13 volts from the source. That's the 7.3 it's dropping. And here's the 5.6 that this guy is dropping. So all total, that comes up to about 13, which is what our source is. So you have to be careful, use some discretion. But you probably already learned something about a Zener just by watching this video. Doesn't matter what the current flow is, we can increase the current going through it, but the voltage drop is always going to be the same across that guy, and you'll see that as you do your experiment. So hopefully this is starting to make a little sense to you, and so Lab 28 is doable using Fallstat.